Everybody good? No problem, no problem. Alright, we good? Everybody else good? Okay. Alright, so I'm just fixing to give us a variety of different problems involving exponents and radicals, and we'll talk about all those rules and properties as we use them. Okay? Okay. Alright, so we got here 2 to the 3/4 times 2 to the 1/2. Alright, this actually comes from the product, the first one that you wrote down. When we've got same base, the 2 is your base, the big number is your base. When we've got same base with exponents and you're multiplying, all you do is take that base and you add the exponents. Okay, you're going to be able to skip some of these steps. I'm just showing you everything as we do them now. Now, 1/2 is the same as 2/4, right? So 2/4 plus 3/4 is 5/4. Now, what's going to be tricky to you is when do I get to leave that as my answer and when do I have to go farther? If it'll simplify down to a whole number, your answer to a whole number, you go farther. If it won't, you leave it like it is. Remember from yesterday, this is power over root. So I'm asking myself, will that simplify any farther? Well, 2 to the 5th, I think, is 32, right? Is there a perfect 4th of 32? No, because 2 to the 4th is 16. 3 to the 4th is like 343 or 81. So there's no perfect 4th, so I'm going to leave that like it is. Now, for you to just do a quick check on your calculator and see, you just type that in your calculator and see if it gives you a whole number. Okay? Pretty simple, pretty simple. Same base, multiply, you add them. Alright, what did we got 3 over 3 to the 1/4. Okay, so now it's same base with division, so you're looking at that quotient rule. What do you do when it's same base and you divide? What do you do with exponents on that? Subtract. Very good. We added them, multiply, so we're going to subtract. What's tricky is the 3 on top. What's the understood power on that 3 on top? A 1. Now, if I'm subtracting 1/4, it helps me to know that that's the same as 4/4, isn't it? So 4/4 minus 1/4 would be 3/4. Does that simplify down any? Got me a whole number for 3 to the 3/4 power? Nope. Mason's right, so that's it. Subtract it. I didn't show that step, Malia. I'm sorry. 3 to the 1 minus 1/4. That's what we did. Yes, division, they get subtracted. You got it.
Where's our test in here?
Next Friday. Looked at that yesterday. Alright, this one that we're going to look at here, it's going to combine some stuff. I got 20 to the 1/2 over 5 to the 1/2 all to the 3rd. Okay, if you look down at the power of a quotient, see that one that you copied down on power of a quotient? It had that M outside the whole thing, and so it gave it to the top and the bottom, right? So that 1/2 that's on the top and the bottom could have been outside the whole thing at one time, right? So this could have been the same as 20 over 5 to the 1/2 to the 3rd, right? Now you follow that? So what that did now, you got something somewhere that says power to a power on that list? That's the way I say it. Let me see the way your book says it. Yeah, power of a power. What do you do on power of a power? What does it say to do? Multiply them. Very good. So this will be 20 over 5 to the 3/2. Okay, now we could do this a couple of different ways. Can't I simplify 20 divided by 5? That gets me a whole number. So I've got 4 to the 3/2. I got a feeling that'll go farther. And here's a way you can know. I mean, you can just check it in your calculator. Yeah. Now remember from yesterday, it's power over root, right? Over root. So I'm doing the square root of 4. And I know 4 is a perfect square. So I'm going to have to go a little bit farther on this one. Square root of 4 is 2. No, we started off. No, say that again. Power. We started off with power of a quotient, and then we went to power of a power. Now we're simplifying. So 4 square root of 4 is 2, and then what's 2 cubed? 8. So is that what y'all got for your final? Bottom number is your power. Bottom number is your root. So that's the same as the square root of 4 cubed. Square root of 4 is 2. 2 cubed is 8. 2 is 2 plus 2. Root. Let's do another exponent ones before we look at some radical ones. Radical. There you go. We need on that? Alright, I got 5 to the 1/3 times 7 to the 1/4 all to the 3rd. That time sign looks like a period. Let me work on that. That's a little better. Okay. Well, thoughts on what we could do on this? Product powers, we add them when they got the same base. And 5 and 7 is not the same base. So can't do that. That's a good idea. That's what he just said. Good idea, though.
No, we said power of a product.
Oh, y'all are,
The third one.
Third one. Yes. I'm sorry, David. I didn't realize what you said. I'm sorry. Product of power and power of product is messing with my brain. Yes, that would be correct, David. I apologize. We've got that power outside, so I'm going to, just like saying, distribute it to both of those powers inside. So what will that 5 be? What do I do with the 1/3 and the 3? Multiply them. So 1/3 times 3 is just 1, right? And then what's 1/4 times 3? It's just 3/4, right? Yes. Took the 3 that was outside and distributed it to the powers on the inside. Now, this one is the one that y'all won't like as much because, believe it or not, it's less work, but it confuses you. Believe it or not, that is your final answer. I can't multiply the 5 and the 7 because I've got that. I don't know what 7 to the 3/4 is. 7 to the 3/4 doesn't work out as a whole number. So I just have to say 5 times whatever 7 to the 3/4 is. If 7 to the 3/4 would go to a whole number, then I would go ahead and write it as a whole number and then multiply it by 5. But I know there's no perfect fourth of 7, so that's it. Those look confusing sometimes because you didn't really do a whole lot on that, but that's less work, so it's a good news, bad news scenario. Yep, yes. It's a combination of yep and yes. Yes, yes, yes. It's a new word family. Should use it. Yips.
Yep.
Combination of yep and yes.
Okay.
Alright, I have got, what we're fixing to look at here, we've done this before. I've got the cube root of 135. Alright, directions for this say write it in simplest form. Cube root of 135. So, does something times itself 3 times equal 135? When you do that on your calculator, did it come out as a whole number? No. So what we got to do, we're actually going to be using the product property backwards. So, of the radicals. So I've got to find a perfect cube that will go evenly into 135. So I know 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216. So that's far enough because that passed 135. Alright, I always start at the biggest. I know 125 won't go evenly into 135. 64, will that go evenly into 135? No. 27 goes how many times?
5.
So this is the same as the cube root of 27 times 5. Okay, we did this early in the year. Now, what's the cube root of 27? 3. So this would be the same as 3 times the cube root of 5. That's it. Good job. Remember that? It's been a while. Many moons ago. Alright, this next part's a little bit tougher sometimes. I've got the 5th root of 7 divided by the 5th root of 8. Now this step is important to be able to get to some more lengthy problems that we're going to have in a little bit. As it is, you can't simplify that any. There's no perfect 5th root of 7, there's no perfect 5th root of 8. So you can't simplify it any. Okay? But, for whatever reason, whenever this would be on Anna's magic list, I don't know why, we can't leave a radical in the denominator. It's just one of those math rules. You can't leave a radical in the denominator. So we got to get rid of the 5th root of 8 on the bottom. So in order to get rid of the 5th root of 8, since it's a 5th root, I've got to find a perfect 5th down there. Okay, so we're listing 5th powers right now. 1 to the 5th is 1. 2 to the 5th is 32. Now luckily I can stop there. Reason I can stop there is because 8, I can make 8 be 32. Can I? 8 times what would be 32? 4. So what I'm going to have to do on this is I'm going to multiply by the, what's the 5th root? Doofus, I was thinking of 4. I'm going to multiply by the 5th root of 4, because that's going to make the 5th root of 32, which is a perfect 5. But I can't just mess up a problem like that. I got to keep it equal. So if I did that to the bottom, I also have to do that to the top. Okay?
What are you going to do with that? Multiply?
So on the top, I've got the 5th root of 7 times the 5th root of 5, which would be the 5th root of 28. I said 5, but it's a 4. 7 times 4 is 28. On the bottom, I got the 5th root of 8 times the 5th root of 4. I can't say one number and write another one to save my life. 5th root of 8 times the 5th root of 4 is the 5th root of 32. Now, our whole purpose in doing that is we know what the 5th root of 32 is. It's 2. Now, will the 5th root of 28 simplify any on the top? I mean, we already passed it with 2, so the 32 won't go into it evenly, will it? So that's it. The cube root of 27 came out to play. The 5 didn't have a perfect cube, so it had to stay in the house. So we wrote 27 times 5. Right here, 27 times 5. 27 is a perfect cube, it's 3, so 3 had to come out. 5 is not a perfect cube, it had to stay. 27 times 5 made 135. You're welcome. Alright. 1 over the square root of 11 plus 3. Dilemma with this one is there's a radical on bottom, and square root of 11 doesn't break down. But what's also a little bit new on this is it's got that extra piece, it's got the plus 3. Okay? When we did imaginary numbers a while back, we could cancel an I out on bottom. Like if it was an I, if we multiplied it by a negative I. You multiply it, remember that word, conjugate? You multiply it by the opposite sign. So the conjugate, anytime you've got a radical that's a binomial like that, 2 pieces, one's a square root and one's is not, to cancel that out, you're going to multiply it by the same thing, just with the opposite sign. So on the top and bottom, we're going to multiply by its conjugate. Square root of 11 minus 3. Okay? So on the top, I just got a 1 to distribute to both of those. So that makes 1 square root of 11 minus 3. I just distributed a 1 to both of them. On the bottom, it's got FOIL written all over it now, because that's a binomial times a binomial. Okay? Square root of 11 times the square root of 11. It's the square root of 121. 11 times 11 is 121. Outer, be negative 3 square roots 11. Inner, positive 3 square roots 11. And last, negative 9. Now remember, my whole purpose in this was to make the radicals cancel out. And I've got 3 written there. But, look at this. Negative 3 square roots 11, positive 3 square roots 11. He gone. Square root of 121 is 11. So I end up out of that with just 11 minus 9, which is 2. So there's your final answer.
I did not see that.
Bam. Hit you out of nowhere.
Wait, where did we get to?
11 minus 9. Because the square root of 121 was 11. And then we have the minus 9. Alright, let's get to something back more normal real quick. I got the 4th root of 1,296 over 25. Okay, what are you trying? You're just sitting there like an autolog. What are you trying to do? What would be something?
Well, I divided, but it's a decimal.
Okay. Okay, so that would be what I would have tried first as well. Let's see if those would go evenly, and they didn't. Since they didn't, then that means I need to look at this. Because remember, 4th root in the whole thing means you 4th root both pieces. Is 1296 a perfect 4th? Anybody know? Remember how to do that on your calculator?
We're doing 6.
Okay, so that would be the same as 6 over the fourth root. I know 25 is not a perfect fourth. Same as 6 over the fourth root of 25.
You
All right.
just stuck to the fourth power?
Okay, we got to figure out what perfect 4 25 will go into. So we know 1 to the 4th. We know 2 to the 4th is 16. 3 to the 4th, 3 times 3 is 9 times 3 is 27 times 3 is 81. 4 to the 4th, 4 times 4 is 16 times 4 is 64 times 4 is 256. I bet it's going to be this one. 5 to the 4th, 5 times 5 is 25 times 5 is 125 times 5 is 625. Is that right? Okay, so 25 times what would make 625? 25, so we're going to multiply top and bottom by the fourth root of 25.
Wait, why do you do that?
The first perfect fourth that 25 would go into is 625. 25 times what makes that 625? 25.
Oh, okay.
Okay, so on the top, we just got 6 times the fourth root of 25. On the bottom, 25 times 25 is 625, but then what's the fourth root of 625? 5. So you got 6 fourth roots of 25 over 5.
So say if it was like 15 times 25, you do 4 and then square root of 25. I mean 4 through 15. You know what I mean? If it was a different number.
Yes, yes.
Okay.
It is. That's probably the most difficult thing we've looked at in a while. Not all together, but in a while. It'll take us some time, but we're going to keep working. We're going to call that a day and look at that some more. Hey. Perfect fourth root. So we started with this perfect fours. The first one that 25 was evenly into is 625. So we had to figure out 25 times what to get us 625. And now it's 25. So we need to put on the top and bottom of that. So, well, 25 times 25, yes. Does that make sense? Where they do the bottom, you have to do the top. Okay, 6 times that. That's what we got.
It's just gonna be like so.
And then 25 and 25 is that.
So they don't make
And the fourth root of that. It's confusing, I know. We'll work some more.
Yeah, but why don't they just stand? It's cheaper.